Good morning to all of you. Welcome in the class of fluid mechanics and hydraulic machines. This fluid mechanics and hydraulic machines, it covers flow in the pipes, flow in the open channels, before that basic properties of the fluid, and also it will cover the hydraulic machines like jets, turbines, pumps. In pumps it is centrifugal and reciprocating pump. Today we are going to discuss about the fluid classification. In the fluid classification, before going to the fluid classification, let's define the fluid. What is fluid? We can define the fluid. Fluid is a substance that is capable of flowing. That is, it is having the capability of flowing. It has no defined shape of its own. Whatever the container is there, if you put the fluid in that one, it will take the shape of that container. So it is having no defined shape. In general, fluids are divided into the liquids and gases. Here in the fluid mechanics, we deal with the liquids. Fluids tends to flow under the external force or shear stress, even it is just slightly more. So that is, if something external force or shear stress is there, whatever the little value is there, fluid tends to move, tends to flow. That is about the fluid. Next we are going to have the focus on the classification of the fluid. Classification mainly covers the 5 types of fluid: ideal fluid, real fluid, Newtonian fluid, non-Newtonian fluid, and ideal plastic fluid. We will go one by one for defining each type of fluid classification, whatever is classified. So first one is the ideal fluid. What is ideal fluid? Ideal name suggests that it is imaginary, that is not existing in the real world. So it is having the property of no viscosity and incompressibility, that is no compressibility and no viscosity. That is the main characteristics of the ideal fluid. It is having the no viscosity. You can see here also written there, it is having the no viscosity. That means viscosity is 0. What is viscosity? Viscosity is a property of the fluid. Because of that, fluid is having the different velocity of the layers. That means if you see flow in a pipe or flow in the open channel, it is having some depth of flow. So suppose this is the depth of flow, this is the top surface of the water, and it is having different layers. Number of layers are there in between the top surface of the flow and the bottom. So each layer, each streamline, each layer will have some velocity. Suppose bottom, towards the bottom it is V1, above it is V2, above V3, like this, V4. That means each layer will have different velocity. This velocity is because of the, this different velocity is because of the, there is the existence of the viscosity. If there is no existence of the viscosity, then that V1, V2, V3, V4 value may be the same one. So this in the ideal fluid there is no viscosity and incompressibility. We will discuss the compressibility and viscosity later in detail. So fluid, ideal fluid, that means it is the main property, it is having the no viscosity and incompressibility. That is called the ideal fluid. And this is the imaginary fluid. This is the imaginary fluid. It will come under the category of the imaginary fluid. So next we will move to the real fluid. Real fluid, that means what? Real fluid, that means the fluid having the viscosity that is existing in the real world. We have seen the example of the flow in the river, flow in the canals. Different types of fluids are there in the form of liquid, like the milk is there, oil is there, honey is there. So these are the real fluids that is existing, and all the real fluids are having the viscosity. In a simple words, we can define the fluid which possesses viscosity is known as the real fluid. The fluid which possesses the viscosity is defined as the real fluid. So that means viscosity is very important property. Based on that, the fluid can be categorized as the real fluid or ideal fluid. In case of the ideal fluid, there is no viscosity. In case when the fluid is having some viscosity, it comes under the category of real fluid. Now we will move to the next. Real fluid. Then there is the Newtonian and non-Newtonian fluid. If you see the first slide there, here ideal fluid, real fluid, Newtonian fluid, non-Newtonian fluid and ideal plastic fluid. So Newtonian and non-Newtonian fluid. What is this Newtonian fluid? Newtonian fluid, that means in simple words, the fluid which follows the rules of Newton's law of viscosity. That follows the fluid that follows the Newton's law of viscosity is called it comes under the category of the Newtonian fluid. That is the Newton's law of viscosity. That is the, what is this? Newton's law of viscosity. Newton law of viscosity. That means shear stress is proportional to velocity gradient. In case, that is the Newton's law of viscosity, shear stress tau is represented the shear stress. Du upon dy, it represents the velocity gradient. That means shear stress is proportional to velocity gradient. That is the Newton's law of viscosity. If the fluid follows this rule, follows this law, that is the Newton's law of viscosity, in which shear stress is proportional to the velocity gradient, then it is called the Newtonian fluid. Shear stress and velocity gradient. If you say how it comes, shear stress and velocity gradient, let's see here. For the, it is having the different, let's see here. It is having the different fluid layers. It is having the different fluid layers. Suppose this is the top surface of flow. So this is having the velocity of v1, this is having the velocity v1, this is having the velocity v2. So this is, suppose this is v3. So there is a change in the velocity as if moving from the bottom, this is the bottom, as you are moving from the bottom to top, as you are moving from bottom to top in the direction of flow depth, then there is a change in the velocity. Each fluid layer is having the different velocity. So this change in the velocity, because of the change in the velocity, there is a velocity difference creates, and because of that the gradient comes into the picture, and it is because of the velocity change, that's why it is called the velocity gradient. That is, from one layer to two layer, velocity is changed from v1 to v2, and in between that v1 to v2, if suppose depth is dy, so v1 minus v2, it can be written as du dy. So that is the change in the velocity in respect of the vertical distance, that is called the velocity gradient. Y is the direction of depth in the vertical direction, that is the vertical direction. So du upon dy, it is called the velocity gradient. Shear stress is created. So this shear stress, if the shear stress is proportional to this velocity gradient, if shear stress is proportional to velocity gradient, if the fluid follows this law, then it is called the Newtonian fluid, and this is the also called the Newton's law of viscosity, that is the shear stress is proportional to velocity gradient. If the fluid not following the Newton's law of viscosity, that is, in case this shear stress is not proportional to the velocity gradient, then the fluid comes under the category of non-Newtonian fluid. So Newtonian fluid, that means it follows the Newton's law of viscosity, and non-Newtonian fluid, that means it not follows the Newton's law of viscosity. And what is Newton's law of viscosity? It defines shear stress is proportional to velocity gradient. That is the Newton's law of viscosity. Well, now coming to the next one, ideal plastic fluid. Let me erase this one. We'll come to the ideal plastic fluid. So what is ideal plastic fluid? Ideal plastic fluid, that is the fluid in which shear stress is more than yield value, and shear stress is proportional to the rate of shear strain. Shear strain, that means the velocity gradient. Then the fluid is treated as the ideal plastic fluid. See, here is the two cases. If you see, fluid in which shear stress is more than yield value. This is the first case. This is the first one, that is the shear stress is more than the yield value, and second, shear stress should be proportional to the rate of shear strain. That is, the fluid follows to, here the this fluid has to follow both this statement, that is, one is the shear stress is more than yield value, and second one, shear stress is proportional to the rate of shear strain. What is means? For the second statement, that is the shear stress is proportional to the rate of shear strain, that is the velocity gradient. Already you know, when shear stress is proportional to the velocity gradient, then this is called the Newton's law of viscosity. That is this is the property of the Newtonian fluid. This is the property of Newtonian fluid. This is called the Newtonian fluid. First one is what? Shear stress is more than the yield value. That means shear stress is more than some yield value. How you can understand this one? You can take the example of the toothpaste. If you press the toothpaste, the paste may come out from the tube or not come out. It's depending on how much press is there. If you play it lightly, then fluid may, that is the paste, that is in the form of fluid, it may not come out from the tube. Again you press, increase the pressure, then shear stress will be developed more, and again if the resistance is more, then the fluid may not come out. Then again you have to increase the pressure, the shear stress again will increase. So the point will come when the shear stress is enough to come out that means against the shear stress, the fluid, that is the paste, will come out from the tube. That means the fluid is coming out at a certain value. If the value is less than that certain value, the fluid is not coming out. That means you are under the shear stress. If the value of the shear stress is less than that certain value, then you are not getting the output in the form of coming out that paste. That means that certain value is called the yield value. That means you are getting the output when that is the result. You are getting the result when the shear stress is more than the yield value. So in that case, that means shear stress is not like that. When shear stress is something, whatever the minimum value is there, some value is there, maybe yield value may be 4. The value if less than 4, then you are not getting the output. That means shear stress should be more than the yield value. Then it is called the ideal plastic fluid. That means in that case, if you see through the graph, shear stress will not pass through that is the straight line. When shear stress is proportional to shear strain, then you will get the straight line. And if that straight line is passing through the origin, that means it is not the more than the yield value. For getting the more than the yield value, it will have some positive, that is more than it will not pass through the origin. Let us see from the graph. So ideal plastic fluid, how can we define? It is having the two statement. One is the shear stress is more than the yield value. That means you are getting the output when the shear stress is exceeding certain value, that is the yield value. And second statement is the shear stress is proportional to the velocity gradient. So let's see from the graph. Here the shear stress on the y-axis, you can see shear stress is on the y-axis, velocity gradient on the x-axis. This is the x-axis, this is the y-axis, right? So velocity gradient du upon dy, shear stress, you can write it tau. You can see here, this is the ideal fluid. Ideal fluid, that means it is having the x-axis only. This line comes under the ideal fluid. That means if you write here shear stress proportional to du upon dy, that is the Newton's law of viscosity. When this proportionality constant removed, then mu, that is the viscosity coefficient, comes into the picture. That is, when there is no viscosity, mu value will be 0. When its value will be 0, then shear stress will be 0. So this line will represent the 0 value of this shear stress line. That is called the ideal fluid. Ideal fluid, that means the viscosity is 0. Viscosity is 0, that means the tau value will be 0. And this represents the straight line. Newtonian fluid, it represents the straight line passing through the origin. That is the important. Newtonian fluid passing through the origin. That means shear stress is proportional to the velocity gradient. You will get a straight line that is passing through the origin. It will represent the Newtonian fluid. And you can see non-Newtonian fluid, it is having the curve line. It is having the curve line, not a straight line. Not a straight line, that means shear stress is not proportional to the velocity gradient. That's why you are getting the curve, not a straight line. And it is passing through the origin. It is called the non-Newtonian fluid. Next one is the ideal plastic fluid. That means it is the straight line. A straight line, that means it is shear stress is proportional to the velocity gradient, but it is not passing through the origin. It is having some value that is the more than the yield value. That's why it is called the ideal plastic fluid. So there is a difference between the ideal plastic fluid and Newtonian fluid. What is, one is passing through the origin while the other is not passing through the origin. However, both are following the Newton's law of viscosity. Because of that, they are having the straight line. So this is about the fluid classification. In next session we will discuss about the fluid properties. Thank you.